1997, number 6, we're going to look at part B. They want to know why the ionic radius, which is the size of n-3, is larger than O-2. And so n-3 is right there, or well, n and O are right there. Since O is -2, it is isoelectronic with neon, and so is n-3. You notice that neon has two shells, one shell with 2 electrons and another shell with 8. So the nucleus is going to look like this, and there should be 2 shells. So you might think, well, they're going to be the same size, but of course they're not. It all depends on how attractive that nucleus is. And since oxygen has 8 protons and nitrogen has 7, oxygen is going to have a stronger pull on the outside electrons. So let's make that argument. Alright, so let's look at my argument. You remember our goals here are to A, answer the question, B, mention subatomic particles, protons, electrons, neutrons, specific numbers of particles, and then to come to a conclusion based on that evidence. So let's see, the ionic radius of n-3 is larger than O-2 because both ions are isoelectronic with neon and have 2 shells of electrons. Now you notice in this first one I'm saying how they're the same. That's not always a requirement, but occasionally on AP grading keys they do ask that you do that. Essentially to say that the shells are not making the difference. And then I talk about n-3 has 7 protons, so specifically mentioning the number of subatomic particles. O-2 has 8 protons. And you notice this time I'm using a bulleted format, which actually I like a little bit better because it makes sure that you hit all the points. And then the conclusion, therefore, the higher nuclear charge of O-2 will cause a stronger Coulombic attraction. You don't have to say that, but it's really nice. To the valence electrons, requiring more energy to remove them than in n-3. You notice that I mentioned in here removing the valence electrons. That is the definition of a first ionization energy, and they may be expecting you to actually say that, essentially defining what first ionization energy is.